Question 34. The question says line segments AB and CD, they intersect at O such that these two lines are parallel. So let us mark this. This denotes that these two lines are parallel. It's also given that angle CAB, this angle is 35 degree and this is 55 degree, and we are now required to find this angle marked in red here. So as you can see that this angle and this angle will be equal. What I'm saying is angle DB or ABD, angle ABD is equal to 35 degree. This and this are equal. Why? Because they are alternate interior angles. I'll explain to you how. Now, when do we get alternate interior angles? And if you can see these two lines, this is AC and this is BD, and it's given that these two lines are parallel. If you now take AB, this and this, are they not alternate interior angles? These two are parallel lines and AB is the transversal, so this and this form alternate interior angle pair. Therefore, angle ABD is 35. This comes to 35 degree. Now, in triangle BOD by ASP, we have angle BOD plus 55 degree plus 35 degree is equal to 180 degree, and therefore angle BOD is equal to 180 minus the sum of this is 90. So this comes to 90 degree. That's the answer. Angle BOD comes to 90 degree. So question number 35, a case-based question. This is, we have the masses of various planets given, except for Earth, which is given in the exponential form. Every other mass is given in normal form, and we are now required to do this. One, write the mass of the Earth in exponential form. So what we do over here is we are supposed to write this in normal form. So this is given in exponential form. What we do is, what does this mean? 10 to the power 24. It means that if we remove this decimal, we can go 24 places to the right of this decimal. That's what it means. 24 places to the right of the decimal is what we can go. So after 5, starting from 9 all the way to the last 0, there are 24 digits. 24 digits to the right of this decimal is what we can go. This is what it means. For example, I'll put a very small number. If it is 2.1 into 10 square, for example, this means that we can write this in normal form as 2, and then we can move 2 places. So it will be 210. So this is a smaller number which we can comprehend rather easily, and this is exactly what we have done over here. So that's the first question. Now the second bit is about expressing the masses of every planet in exponential form. So here we are just doing the reverse. So for example, if we have 50100 and we are supposed to write this in exponential form, you would write this as 5.01, which means we have moved the decimal 4 places, mind you, 4 places, 1, 2, 3, 4. The decimal is here, so we put 10 to the power 4. This is exactly what we have done. In the question, in the normal form, this figure is having 24 digits starting from here till the last 0. There are 24 digits. So instead of writing this in normal form, what I do is I have shifted the decimal 24 places to the left, and for that, to make up for that, I have written 10 to the power 24. So this is how I express every mass in the exponential form. And after having done all, which I have not done here, this is for your understanding, you should be able to do, you can arrange them in ascending order. The last question is, the mass of the sun is given. The mass of the sun is given as 1.989 into 10 to the power 30 kg. How many times is this more than the mass of Earth is what we are required to find. So this will be x into the mass of the Earth, which is 5.9736 into 10 to the power 24. So let us remove the unit now for calculating things, right? So we have got to find x. Therefore, x will be equal to 9.989 into 10 to the power 30 divided by 5.9736 into 10 to the power 24. So this will come to 1989 by 59736 into 10 to the power 30 minus 24. So that gets us 61989. Here it will be 1.989 into 10 to the power 30 by 5.9736 into. So here you see that this numerator is smaller than the denominator. It needs two more zeros to have the denominator bigger. To have the denominator bigger than this, we need to have two more zeros. So let's borrow two zeros from 6. What I mean to say is, I'm continuing this here, that quantity, this quantity can actually be written as 198900. And where have I got those two zeros from? I have borrowed from here, so I can write this as 10 to the power 4 divided by 59736. Why have I done this? So that I can divide this by this. This comes to approximately 3.3 into 10 to the power 4. That's the final answer. So 3.3 into 10 to the power 4 times. So the sun is how many times the mass of Earth? 3.3 into 10 to the power 4 times the mass of Earth. This is the answer. Question 36. We have some streets. As you can see, this details the various streets. Let's come to what will make sense for us. Find the measure of x. We'll see one at a time. Instead of getting lost in the streets, we can probably answer questions one at a time, and we'll see if we are able to. If we need more information, probably we'll read more of the passage or the details that are given. So in this case, find the measure of angle x. So the first one first. In this case, we can see that these two, angle A plus angle B, they form a linear pair, and therefore they are supplementary. So the reason is linear pair. This will help us find the value of x. So 0.5x plus 45 degree plus 2x plus 60 degree is equal to 180 degree. 2.5x plus 105 degree is equal to 180 degree, and that gets us what? 2.5x is equal to 180 degree minus 105 degree. That implies 2.5x is equal to 75 degree, and therefore x is equal to 75 by 2.5. To get rid of the decimal, multiply both numerator and denominator by 10. So this will be 750 by 25. So this will be 30 degrees. So x comes to 30 degree. Okay, that's the first question. That's the first bit. What is the angle between Kautilya Marg and Teen Murti Marg? So Kautilya Marg is given as this, and the Teen Murti is given as this, and it's given that this and this line are parallel. It's already mentioned here that these lines are parallel. So you can see that angle 1 is what we have marked as the line, the angle that we are now going to find out. Angle 1. What is the measure of angle 1? The angle between the Kautilya Marg and the Teen Murti Marg. Now let's see how to go about solving this. Now you see that this angle A plus 90 plus 1 is a linear pair. Sorry, it's not a linear pair. There are three angles. So 90, this angle A here, this is for the second bit here, angle A plus 90 degree plus angle 1 is 180 degree. Give the reason because this is a straight line. Teen Murti Marg, you can write it like this. Teen Murti Marg is a straight line. Angle on a straight line is 180 degrees. So now let us see what all we can find out. Angle A angle A in this case is 0.5 into x. We found x as 30 plus 45. This is the value of A, plus 90 plus angle 1 is 180 degree. So from here we will be able to find out the value of 1. So 30 into 0.5 will come to 15 degree plus 45 degree plus 90 degree plus angle 1 is 180 degree. So this is 60 plus 90, 150 plus angle 1 is 180 degree, and therefore angle 1 is 180 minus 150, and that gets us 30 degree. That's the value of angle 1, the angle between the Kautilya mark and the Trimurti mark. Alright, let me see how we can find the other angles. 3. If the angle between Mother Teresa crescent and Sardar Patel mark, Mother Teresa crescent, we're talking about the Mother Teresa crescent and the Sardar Patel mark. We're talking about this angle. We're talking about this angle now. We're talking about this angle. This angle is 18% of 166. Let's call this angle 2. So this is the third bit. It's given that angle 2 is equal to 18% of 166 2 by 3. Then how much is angle 2 is what we have got to find. So this will be 100 into 166 2 by 3 will come to 498 plus 2 is 500 divided by 3. So this goes 5 times, this goes 6 times. So this becomes 60 degree. The third bit is 30 degree. And then the angle between C and A, if they are equal, give reason. So C and A, this is the fourth bit. Angle C, as you can see, is equal to angle A. We have already found angle A. Angle A we found as 0.5. So angle A is how much? Angle A is equal to 0.5x plus 45, and that came to 0.5 into 30 plus 45. This is 15 plus 45, so this is 60 degree, and that is equal to angle C. Why is this angle? Why are these two angles equal? Because angle C and angle A are alternate interior angles. These are the measures of the two angles. Angle C and A are equal because they are alternate interior angles. A we found to be 60 degree, and therefore C is also 60 degree. So for question number 37, a flag is a piece of cloth with distinctive designs and colors displaying the symbol of a sovereign state. It is attached by one edge to the staff or flag mast. Well, it goes without saying that a flag is rectangular in shape. So in this case, you would agree that this angle is 90 degree. Let us call this flag ABCD, and let us call this angle angle 1. Here at the vertex B, you would agree that 15 degree plus angle 1 is equal to 90 degree. Why? Because the angle of a rectangle, because ABCD is a rectangle. You can just give this as a reason. ABCD is a rectangle, and therefore this angle is 90 degree. That gets us the measure of angle 1. Angle 1 is equal to 90 degree minus 15 degree, and that is equal to 75 degree. So this angle is 75 degree. This being an isosceles triangle, this will also be 75 degree. If we mark this A, then you can see that triangle BEC is isosceles. BEC is isosceles. And therefore, if angle 1 is 75 degree, that implies angle BCE is also 75 degree. Hey, this is 75. And this is an isosceles triangle, which means this side is equal to this side. So this angle will also be equal to 75 degrees. Now in triangle BEC, how? In triangle BEC, by angle sum property, 75 plus x is equal to 180 degree, because this is 75, this is 75, and this is x. That gets us 150 plus x is equal to 180 degree, and therefore x is equal to 30 degrees, the answer. That's the first one. Name the type of triangle, the white triangle. This is showing as the white triangle in the figure. So the white triangle is an isosceles triangle. So this is 1 and this is 2. So in this question, we have got to find the value of n. So, as in the earlier questions of this type, let us first factorize, express every number as prime factors. Let's see where we get it by doing that. So that gets us 9 to the power n will become 3 square to the power n into 3 square into 3n. We're not doing anything to these because they're already in prime factors. They're already expressed as in prime factors. There's nothing we have got to do here. So this will be 3 to the power 3 to the power n divided by 3 to the power 3 to the power 5 into 2 cube. And that is given by 1 by 27. So 27 can be written as 3 to the power 3. So in this step, all we have done is wherever we encountered composite numbers, we expressed them as prime factors. That gets us what? That gets us, look, all the bases are 3, so we can write this as 3 to the power 2n plus 2 plus n minus 3 to the power 3n divided by 3 to the power 15 into 2 to the power 3 is equal to 1 by 3 cube. And over here, make sure to write all the laws of exponents that we have used. In this case, we used a to the power m into a to the power n is equal to am plus n, and we also used a to the power m, the whole rise to n is equal to a to the power m into n. These are the two laws that we have used. Let's see what else we get. So that gets us 2n plus n becomes 3n, 3 to the power 3n plus 2 minus 3 to the power 3n by 3 to the power 15 into 2 cube is equal to 1 by 3 cube. I'm continuing this here. So in between these two, I can express this as 3 to the power 3n into 3 square. This can be written as 3 to the power 3n into 3 square. It's the same. I'm using this exponent in the reverse way, the converse way, because I see the second term being 3 to the power 3n. In the next step, I'll be able to take these two things common. In this, you'll apply the reverse of distributive law. So in this case, this gets to 3 to the power 15 into 3 to the power 2 to the power 3. Sorry, this is 2 to the power 3 is equal to 1 by 3 cube. So I can take 3 to the power 3n common here. So that gives me, I'm left with 3 square here and minus 1. It's the converse of the distributive law, mind you. In this case, I have taken both of these terms had 3 to the power 3n common. So that's what I have taken common. After taking 3 to the power 3n common, I'm left with 3 square over here and I'm left with 1 over here. And that is 3 to the power 15 into 2 to the power 3 is equal to 1 by 3 to the power 3. It's very interesting. 3 square minus 1 is 8. And this is also 8. So this will get knocked off. 3 to the power 3n into 8 by 3 to the power 15 into 2 to the power 3, which we can write as 8, is equal to, In this case, because I'm eventually going to compare the power of 3, let us write this as 3 to the power minus 3. Because I'm going to eventually compare the power of 3. So this gets us 3 to the power 3n minus 15 is equal to 3 to the power minus 3. Therefore, 3n minus 15 is minus 3. And that gets us 3n. Transpose this to the other side, it becomes plus 15. So plus 15 minus 3 is 12. And therefore, n comes to 4. That's the answer. N is equal to 4 is the answer. So in this question 39, it's given that PQ is parallel to RS. So let's mark that PQ is parallel to RS, given PQ is parallel to RS, and these angles are shown. We've got to find the value of angle PXR. To find angle PXR. So in questions like this, to make use of the various pairs of angles that we are familiar with when two lines are parallel, let us draw a line passing through X which is parallel to both of these given lines. So what I mean is, let us draw a line, let's call it AB, or any line as you may please. Draw line AB, line AB parallel to PQ, which is also equal to RS, because PQ and RS are already parallel. If you draw a line parallel to PQ, it will automatically be parallel to RS. See, at this angle, let's call it 1. Therefore, angle 1 is equal to 70 degree. Alternate interior angles. And if I call this angle 2, then angle 2 and 50 are again equal because they are alternate interior angles. Angle 2 is equal to angle 50. Sorry, not angle 50, it's 50. That's a measure, 50 degree. And this is equal to alternate interior angles. And I'll explain you how this happens. Look, this is PQ and this is AB. This is AB. So if I have a line something like this, will this angle, which is 70 degree, this is AB, mind you, and this is angle 1, mind you. So this and this, are they not alternate interior angles? And for same reason, 50 and 2 are alternate interior angles. Now, what is angle PXR? Angle PXR is equal to angle 1 plus angle 2, is it not? 1 plus 2. And we found 1 to be 70 and 2 to be 50, and therefore 120 degrees is the measure of angle PXR. So in question number 40, the figure is given as this. We have these lines parallel, that's indicated by the arrows, and it's given that angle MLY is twice of LMQ. That's given. So we have taken this as X and this as 2X, because it's given that this angle is twice of this angle. So I've considered this as X. So let angle LMQ be equal to X, and therefore it's given that MLY is equal to twice of X. We are required to find angle LMQ. So in this case, we are required to find angle LMQ. We are required to find angle X. Now we know these two angles are co-interior angles, and co-interior angles are supplementary. Co-interior. Therefore, 3x is equal to 180 degree, and that implies x is equal to 60 degree. That's 1. Now let's look at 2. In 2, we have angle XLM. Angle XLM, we are talking about this angle, is 2x minus 10. this is 2x minus 10 degree, and LMQ is x plus 30. LMQ is x plus 30. So if I've erased the data from the first bit because this is another bit and we have to use fresh set of information here. It's given that this is the scenario. We know that these two angles are alternate interior angles. The two angles are alternate interior angles and therefore they are equal. Therefore 2x minus 10 is equal to x plus 30, and if you transpose x 10 on the other side, it becomes 40. So in this case, find x, and that's equal to 40 degree. Angle XLM is equal to PML. XLM is equal to PML. Now let us erase the data from the previous bit and see what else. Angle 3. Now in this case 3, angle XLM, we're talking about this angle XLM, is equal to angle PML, this angle. So it's given that these two angles are equal. So if this is angle 1, this is also equal to, this is also equal. Find ALY, find ALY. So we are required to find this angle, angle 2. So angle 1 and angle 2 are equal. As you can see, angle 1 is equal to angle 2 because they are vertically opposite angles, and also these two angles, they are supplementary because they form co-interior angles. Also twice of angle 1. Hey, because this and this together they form co-interior pair, so these together will be 180 degrees. So twice, if this plus this is 180, can't I say that twice of angle 1 is 180? So twice of angle 1 is equal to 180 degree, and therefore angle 1 is equal to 90 degree, and because angle 1 is equal to angle 2 is also 90 degree. So this was the one that we are required to find, and this comes to 90 degree. Beautiful. Next, fourth. Let me erase everything so that we use the fresh set of data for the fresh bit. Number 4. It's given that ALY, this is given as 2x minus 15. And LMQ, this angle is x plus 40. Now here again, these two angles, the two angles are equal because they are corresponding angles. That gets us what? 2x minus 15 is equal to x plus 40. Let's transpose x. So this gets us x. 15 on the other side makes it 55 degree. So we have the 4 answers. 1, this is 2, this is 3, and this is 4. Okay, so in this question number 41, we have this triangle and all this information is given. And we are now required to find angle BDE. So we are required to find angle BDE. Let me highlight this, the one in the first bit that we are going to determine, angle BDE. Angle BDE, this is the angle that we are interested in at this time. So see, in this case, if I mark this as angle 1, can I say that 130 degree plus angle 1 is equal to 180 degree, linear pair? And therefore, angle 1, if you transpose, it comes to 50 degree. So angle 1, it is coming to 50 degree. Now, in triangle ADF or AFD or FAD or DAF, whichever, in triangle DAF, by angle sum property, do you see that angle D plus angle DAF plus angle 1 is equal to 180 degree. Now angle D is what we have got to find. Angle DAF is 90. This is 90. This also has to be 90. This is 90 degree, and angle 1 we just determined, it's 50 degree. So that is 180 degree, and therefore angle D will be 180 minus 140, and that gets us 40 degree. That's the first bit. That's the first bit. The next thing that we are required to find is angle BCA. Angle BCA is the other angle that we are required to find. Now, if you see angle, now this will be a two-step exercise where you can see that this is 90 degree, and because this and this are vertically opposite angles, this is angle 1. So we are now interested in the second bit. In triangle FEC, angle 1 plus 90 degree, let's call this angle 2, or let us just name it ECF or EFC, angle BCA. In fact, FEC is same as BCA. FEC is same as BCA. Let us write FEC for now. FCE, and that is equal to 180 degree. We have just found the value of angle 1 as 50 degree. A while ago we found angle 1 as 50 degree. So this will be used here. This will be useful here. 50 degree plus 90 degree plus angle FCE is equal to 180 degree, and therefore angle FCE is equal to 180 minus 140 is equal to 40 degree. Now this is angle FEC, and it's also angle ACB or BCA. BCA, therefore angle BCA is equal to 40 degree. You'll see that angle BCA and FCE are the same angle. So this way you can find the value of this angle BCA. For question number 42, two poles of height 6 meters. So let us represent these poles as AB. Let AB equal to 6 meters and CD equal to 11 meters. Represent the two poles. It's given that the distance between their feet, given BD is equal to 12 meters. Therefore, you can see that BD is same as AE. Therefore, AE is equal to 12 meters. Now, what are we required to find? We are required to find AC. As you can read from the question, the distance between their tops. So, A is the top of the pole AB and C is the top of the pole CD. We are interested in finding AC. Now, you see that these poles stand vertically. So, this will be 90 degree. And because this and this lines are parallel, this is also 90 degree. So we don't have to write all the details, but you can see that in triangle AEC, by Pythagoras theorem, the hypotenuse square, which is AC square, is equal to AE square plus CE square. Well, CE now, where CE is not given, but we can find out. CE is CD minus ED. Hey, CE is what we are interested in. So we find CD, and from that we subtract PE. So CD is given, this is 11, and ED is same as AB, and that is equal to 6 meter. So this becomes 5 meters. Now if we get here, AC square is equal to AE square, which is 12 square, and CE square is 5 square. That gets us what? AC square is equal to 144 plus 25. Therefore, AC square is equal to 169. You will have to determine that number, which when multiplied by itself gets us 169. And mind you, the hypotenuse is the longest side. So if this is 12 and this distance is 5, Obviously, AC is going to be more than 12. So start from 13. Try 13 into 13. Yes, the very first try gets us the value of AC. So AC is equal to 13 meters is the answer. So in this question, we have a triangle where the measures are given in these terms. Thrice of angle P is 4 times angle Q, and that's equal to 6 times angle R. So we have got to find the measures. Now we know that angle P by ASP, angle P plus angle Q plus angle R is equal to 180 degree. This is known by the angle sum property. Let us now write everything in terms of 1. So let's see what we get. Thrice of angle P. Can we multiply this equation by 3 so that we get thrice angle P, and we'll see what all. But overall, so that we make use of this information, let us multiply this equation by 3. Multiply by 3. So we get thrice of angle P plus thrice of angle Q plus thrice of angle R is equal to 3 into 180 degree. That gets us thrice of angle P, which we can write as 4 times angle Q. 3P can be written as 4Q. So 4 times angle Q plus 3 times angle Q. Let us find out the value of, so in this case 4Q, look, 4Q is equal to 6R, or 6R is equal to 4Q, and therefore can I write R as 4Q by 6? So this will be 3 into R is how much? 4Q by 6, and that is equal to 540 degree. By expressing everything in terms of angle Q, I will be able to find the value of angle Q here. That's the overall idea. So for 3P, I have substituted 4Q. 3Q I have not changed because I want everything in Q. So this is in Q, already in Q. I'm not changing it. It remains in Q. And for R, instead of R, I'm substituting this as 4Q by 6. Now I'm continuing here. So I get 4Q plus 3Q. That becomes 7 times angle Q. Plus, you can cancel this and this. And 2 and 2. So 7Q plus twice of angle Q becomes 540. That implies 9 times angle Q is equal to 540. Therefore, angle Q is equal to 540 by 9 is equal to 60 degrees. So angle Q is equal to 60 degree. That's one done. Now we know that, we know 3 times angle P is 4 times angle Q. That implies 3 times angle P is equal to 4 into 60. Therefore, angle P is equal to 4 into 60 by 3. So this is equal to 4 into 20, that's 80 degrees. So angle P comes to 80 degree. Let us now also find the last one. So now I know angle P. So I can compare this 3P. We know 3 of angle P, 3 times angle P is equal to 6 times angle R. That implies 3 times 80 is equal to 6 times R, and therefore angle R comes to 3 into 80 divided by 6. So angle R comes to 40 degree. You can verify when you add all 3, you will get 180 degrees. So what do we get? Angle P is equal to 80 degree, angle Q is equal to 60 degree, and angle R is equal to 40 degree. That's the answer. So with this, we have come to the end of this worksheet. There were a total of 43 questions. We have solved all. Go through all and get to understanding the concept, the underlying concept across every question. It becomes easy. You will be able to solve any question under the sky once you have really got deep into the concepts. Thanks all for watching.